In this video, we'll continue with the hands-on exercise from Tuesday, looking at some of the functionality of Pandas. And after we import the module here, let's just go and download the data, some water quality data. Now, one thing that's happening is that with this URL here, we use the read.html function to parse the tables in the web page. Now what Pandas will do is we'll look for the table tags in the HTML source and then try to capture as many tables as are available. So then it's our job to look for the table where we are interested in. So it's still reading, so let's take a look real quick at the length of df. And the length is 6, so we get 6 tables back. Now, if we can either do this manually, so we can say, well, the first table is this, the second table is this, and so forth, until we get to the point of the 5th table, which actually is what we're looking for. So this is has columns of date, temperature, and turbidity. Now, the index of this data frame, as you can see, because we weren't explicit at what the index should be, it just goes from 0 all the way to the end. Now, if we want to pick an appropriate index for our data, the most appropriate index would be date. So let's take a look here. We're using the setIndex function, and we're getting the date as an index. You see that it's in bold letters now instead of and replaces this range index. Now, if we look at the documentation of read.html, let's do that. We'll see some other interesting arguments that we can use. The first one is parse dates. The second one is the index column. There's a number of other ones that we can decide to keep. But let's take a look first at the df index and look at its type. So you see it's an object. So it's not really a date per se. So what we can do is we can say pd read html and then we can say URL and then we can do index column, and we're going to grab the first column. And there's a reason why we don't put date here, and I'll explain in a little bit. And then parse dates, and then we can put here true. So now if we select the 5th table here, you see that we have a new table. It looks very similar to the other one. So what I'm going to do, and this is something I want to talk about, because I don't want to reread the URL, Jupyter Notebook allows us to grab the result of a previous operation by just using underscore and the number of the cell. So you see 12 gives us this. So in order for me not to reread it, I'm just going to take this argument here instead of rerunning it. But what we want to do is let's take a look at the index here. Oops. You see now the data type changed. It became datetime. That's because we said parse dates equals true. So now it understands that this is not just an object, but it is actually a date. And we can do things like, this is the first timestamp, and we can say, give us the year, and you see that it works. So there's a number of methods that we can use with this type of data. All right, notice the column headers are hyphenated, so let's get rid of this. So the fastest way to do this would be to use the string submethods of the column sequence and then replace the dash space with nothing. So again, let's do df head here. So you see that this works for the columns. Now if we try to calculate the mean of each variable, we could do it with this. So we can call the function mean. There's also variance, standard deviation, and so forth. So you still be getting an empty array. And the reason is that we have malformed data. So we have these A's, we have some, if we actually look at the entire, oops, we have some P, we have some bracket 4. So if we look at the first element, we'll see, for example, here, if we do temperature, and with tab, the nice thing is that it will actually complete this, so we don't have to type this whole thing. But if we look at the type, it's d type 0, which doesn't really tell us much. But if we do this, 0 actually corresponds to a string, and let's see if this works as well. Actually, there's no type, but here what we can do is we can do type, and you see that it's a string. So now there's a couple of ways we can replace these flags, so A and P. And the first one would be to just use replace everywhere. And so you see that we replace A's with nothing, P's with nothing, and then bracket 4 with nothing. Now the bracket 4, the bracket needs to be escaped because it means something in Python. So we need to make sure by using backslash that we tell Python, hey, this is an actual bracket, not the index that you're used to. So if we run this, oops, it doesn't work. The reason it doesn't work is when we use replace for data frame, then it looks for an entire A or the P, or the bracket 4. So there's got to be a better way for us to do this. And the one way we can do this is we can write a function. So in order to write a function, we see a pattern here. First of all, we see that the numbers are only in the first 3 positions, right, for most of them. Although here we have something in the 4th position. So the one thing we see though is that the flag is either P or A, provisional or approved, and then it might have some more things in there. So why don't we try to write a function? So let's write a function here that says def clean, let's see, clean value. And let's say that we get a value that's a string. Now, we can find the index of the string, because remember, a string is a sequence. So we can say find where you have A. Now, if this is greater than 0, it means that it found A, and it will tell us the position where it's at. So let's first do the index of A, and then let's also find the index of P. Now, if it doesn't find the string, then it will just say, oops, it's -1. So what we can do is we can say, well, if IA greater than 0, actually we can do this. So if IA is greater than 0, we can return the float. So actually, let's result, or let's change this into val. So we would get the float of the string all the way up to IA. Right? So with this one, we're essentially grabbing the values of the string 0.9, and then we stop right here, because this is where the index was returned for us. Now we can do elif IP greater than 0, and we can do the same thing. And then we can have another one, which is basically just give us the entire string if we didn't find approved or not approved. So then we return the value. Okay, and then let's try it by calling it on a single element. So we have temperature maximum, and then we're going to grab the first one. There we go, 0.9. It's what we expected. Now, one of the nice things about the data frames is that we can apply a function like this over entire columns. In this case, our clean value function does not operate on an entire column, but it operates on cells. So Pandas provides a function that's called apply map. And let's look at that, what it does. Apply map applies a function that accepts and returns a scalar to every element of the data frame. On the other hand, if we do apply function along an axis of the data frame. So that would be a column, but it also could be a row, but it gets applied over a sequence. Now, remember everything is an object, so we're passing the method, the function object directly. So if we run this, we got an error, so let's see what's going on. So float object has no attribute find. Okay, so what this tells us is that not all the values in our data frame are strings. Sometimes they're floats. So we have to capture that. So the first thing we're going to do is we can say if is instance s string, then do everything here. So let's mark this and let's tab, and then what we can do is we can say else val equals s, and we got an error again. So let's see what we got this time. Name is a typo. If is well, it didn't change color, so I should have known. There we go, and there it is. So with this function here, what we're doing is first we're checking to see if this scalar is a string. If it is, then we find the position where it's a and p, or p, and then depending on those conditions, we capture only the part that is an actual number, and then we apply the map. So let's save, replace our original value. So that's df. So now let's try the mean calculation again, and there we go. So now it works. All right, let's keep going. Count the days with missing data for each column. Now, if we had missing data, they would be null. So let's see if there's a function here with null. If we go, let's see, is NA is null. So let's do is NA. Return a boolean, same size object, again if the values are not numbers. So let's see here. So is NA gives us true or false. Now what we could do is we can apply the len function, and this will give us, first of all, this will give us the length of each column, which is not exactly what we need, right? So we have 389, which is not what we need. However, what we can do here is we can say we get, let's see, true, false, true, false. So we can only keep the true values here, or we can do is null, and we get the same thing. So is NA is null is the same, and then we can apply another function. So here the column, and we return the column and we select, again, we pass the sequence of true or false, so it would only keep the true values. So let's see what this returns. It gave us where it's true, meaning where it's null. So remember that apply works on the entire sequence, on the entire column. And that sequence, we can treat it as a NumPy array. So what we're doing here is we're saying, give us, for that column, only select, filter out, only filter in, actually, what's null. So based on that true or false. And then we get the length of that. So you see the missing data on each column. So if we find the dates now when we have the missing data for mean temperature, so we just select a single column. So let's name this average temperature, and we have, there we go, average mean. So let's see what we've got. Okay, here we go. So let's find the dates where we have missing data. So again, we can do this. Oops. There we go, we have true or false. Now, we can use, there's another way now, we can use the location, and what that will give us, let's see if this works, and we got the dates exactly as, and then we can just grab the index of that, and there we go. And you can see that the mean temperature actually did have 3 missing data. There's a few other ways we can do this, but this is another. I just wanted to showcase the use of the keyword lock. Okay, so find out if no variable was measured when data are missing for at least one variable. Now let's go and see here again the isNA function. So isNA again returns the true or false. So that doesn't really do much, because again we're looking for if the entire row has if no variable was measured when data are missing for at least one variable. So we're looking for times when every variable was missing. So in this case we're going to need the drop NA. So, oops, drop a name. Or we can look at, we looked at isNA, so let's look at actually isNull. And you see that that does the same thing really, so it doesn't really help us. But if we look at the other related function, which is drop NA, so this will remove the missing values. And this is where we need to look for, what we need to look for. How? Determine if row or column is removed when we have at least one NA or all NA. So what we're looking for is, first of all, we need to operate in terms of rows. And then we need to operate, so let's see here. So if we do drop NA, you see we got 380 columns, compared to what the DF was 389. Now with this, you see here that it removes when we had at least one NA, which is the 9 here. So this immediately tells us that some of these dates coincide with these dates here. So with this now, what we can do, we can say, well, all instead of the default of any. So now you see we got 386 rows, which means that we essentially have less. So if this is less than the length of DF, which is actually, oops, let's see, the length of this, if it's less than the length of DF, true, we did have days where all measurements were not taken. All right, and finally, let's use the plot function here of the data frame, which we haven't really talked about, but this again gives you a little bit of an idea of how we can plot data very easily, and we're going to cover that next week. But it sort of gives you, with one command, you kind of get both a legend, different colors, dates here in the x-axis, and then the y-axis you get the actual values. And then in terms of correlation, again, this is another internal method of you can see we can get covariance, we can get correlations. There we go. So if there are multiple columns, it will give us a table that essentially looks for the correlation between the different variables. So you see the maximum temperature obviously with itself is 1, but then you see the high correlations with other temperature and so forth. All right, and with that, hopefully this again made sense. As I said before, there's multiple ways we can do this. A lot of these different exercises, but I'm happy to answer questions on Thursday.